Okay, this lecture is about reducing methionine and advanced glycation end products to slow down aging, to help prevent cancer. This is going to be a longer lecture. I just gave a recent lecture about this, hitting the main points. This one's going to go in more detail, more of the subtleties, more about, some subtleties, things about beans, some subtle things about fruits, and a little more of the biochemistry. So this is for people who really want to know, especially if somebody is especially concerned about aging rapidly or about cancer. Okay, excuse me. Kind of got like half a sneeze and I'm like, doesn't know what it wants to do. All right. Soybeans have a lot of protein, about 38% of their calories from protein, super high. Soybeans also have a lot of fat, about 46% of their calories from fat. That's one of the reasons why I don't like to eat soybeans. My favorite bean is lentils. Lentils, though, are also a little bit high on the percent of calories from protein at about 31% of calories from protein. The benefit of lentils, though, is they've got much lower fat, only about 3% fat. Lentils also are higher in fiber, so that's good. The bean that's second highest in fat is chickpeas, also called garbanzos. They're about 13% of the calories from fat. Let's see. Another problem with soybeans have a lot of iron. They, just one serving is about 50% of RDA, recommended daily allowance for iron, whereas most other beans are in 20-25% ballpark, which I would find preferable because men start becoming iron overloaded at 20 years of age, women at postmenopausal, let's say around 50 years of age, and being iron overloaded predisposes you to oxidative stress, which increases cancer risk, inflammation, atherosclerosis, etc. If I were diagnosed by cancer, I would want to keep my ferritin on the low side. I've given previous lectures on that, and I donated blood once to get my ferritin down lower to where I wanted it. It wasn't that high, but I wanted it optimal. So that's pretty much the scoop on beans. Even though they're associated with good longevity, and that's been shown in several different studies, they are very high in protein. So whenever I eat beans, I always dilute them in a sense by eating them simultaneously with rice or potatoes. And I'm sort of in the trend of coming down a little bit on my bean intake. They're just convenient, and I often have them cooked for me, so they're just there when I come home. Fruits are a great way to minimize methionine. We're going to talk about how to minimize methionine. They're very, very, very low in methionine, and then they're high in all kinds of other good things. Magnesium, protein, fiber, antioxidants, and vitamin C. Okay, a couple thoughts on cancer and nutrition. The typical conventional oncologist, these are their standard tools. Chemotherapy, immunotherapy, which is similar to chemotherapy, hormonal therapy, let's say with a breast cancer that's hormonal sensitive, tamoxifen, for example, estrogen blocker, radiation therapy, and surgery. And that's all well and good, but now some oncologists are developing a little wider range of tools, and they're starting to use repurposed medications. For example, aspirin can actually have an anti-cancer effect. So can some other medicines. In some cases, metformin, in some cases, statin drugs. And there's a whole bunch of other drugs that can also have potential anti-cancer effects. This book by Jeffrey Dodge is a whole book on repurposed drugs to be complementary to conventional chemotherapy. And that might increase effectiveness because a lot of times the chemotherapy will only block one or two pathways, and the cancer cell just figures out how to go around them. If you simultaneously block 3, 4, or 5 pathways, you might get better effects. It has to be done skillfully, though, so you don't get too many side effects. And, I think time is long overdue that so-called nutrition therapy is added or substituted for in some cases. It depends on the cancer, of course. Okay, chemo is great for testicular cancer, some lymphomas, and some other cancers, too. There's a lot of other cancers, though, it doesn't work so well for. The benefits of protein restriction are well described in this classic book on the relationship between protein and cancer, the China study by T. Colin Campbell. It's a masterpiece, one of the best vegan nutrition books ever written. And basically, what did T. Colin Campbell show? He showed that in mice and rats, when you take casein, which is milk protein, and you decrease it from 20% of calories to 5% of calories, they don't get any cancer. This is, for example, liver cancer in the context of aflatoxin in moldy peanut butter or hepatitis B virus. By dropping the amount of animal protein in the diet, he could dramatically, in a sense, almost turn cancer on and off. That's all described in detail in this book, and rather remarkable. So what's thought to be the mechanism? That animal protein sort of activates growth, activates cell replication. There's some different reasons for that. Activation of mTOR, for example, it tends to be associated with increased insulin-like growth factor, for example. Okay. So that's good to know. He could turn it on and off, and he said that other research had found similar findings, not just with liver cancer, but with breast cancer and with pancreatic cancer, for example, he talked about in his book. And most of that research is done in mice, but some research has been done in humans. That's a developing thing. Other things that'll help a cancer patient be healthier and really help anybody to age better. Sleep better, which means avoiding caffeine, controlling one's stress. Stress reduction can be other things. Social support, having a support group for your cancer or your disease or whatever else is of interest to you. Meditation in some people. Religion and prayer. Religious people, they're healthier. That's, Harold Konig's book has shown that perhaps best, but that's pretty well known. Seventh-day Adventists, longest lived people in the world. Music can be very therapeutic. It's soothing. It puts you into more of a parasympathetic autonomic mood, a relaxed mood. That's feed and breathe, rest and digest, in comparison with a stressed mood, which is sympathetic autonomic nervous system, or SANS, SANS, and that's associated, with higher heart rate, increased cortisol, which is immunosuppressant, etc. Exercise also helps cancer patients because once they get exercise and they're compressing all their lymphatic vessels throughout their body, which pumps their lymphatic fluid around, that facilitates the immune system cells to better surveil the body for cancer cells. It's a common thing. You'll see a lot of these people who survive metastatic cancer, like Ruth Heidrich. Here's one of her books, Senior Fitness. Here is Janet Murray Wakelin. Here's her book. Oh, no, this is Kathleen Turner's book. She talks about that, too, in Radical Remissions. Oh, I had the other book around here, too. Oh, it's right here. It's right here. Raw Can Cure Cancer. This was Janet Murray Wakelin's book about, and she's also a marathon runner like Ruth Heidrich. So exercising can really help a lot to facilitate the body getting a hold and controlling cancer. Getting sunshine. You increase vitamin D. I think the best way to increase vitamin D is go out and get sunshine. That's much better than taking medication, oral pills for vitamin D. Other benefits, low-fat diet. You're going to oxygenate your tissues better. You're going to be skinnier. You're going to have less diabetes, hypertension, atherosclerosis, all those things that make cells hypoxic. Hypoxia is a big deal because hypoxia favors cancer. Hypoxic, that means low oxygen tumor environment, milieu, favors cancer growth over normal cell growth and growth control of the cancer. And that goes back to Warburg effect. Warburg is the German biochemist who won the Nobel Prize in 1931. Took a bunch of tissue cultures and he would deprive them of oxygen. Once you get up over 35%, the cells in the mammal tissue culture would start dying. And some of them, though, would transform to become like an anaerobic bacteria. That's basically what cancer is. That the normal cell transformed into running on glycolysis. You can call it aerobic glycolysis, but it's an anaerobic form of metabolism, predominantly anaerobic, using tons of glucose, and that's the Warburg effect. So anything that improves oxygenation to a tissue helps prevent cancer. So low-fat vegan diet tends to do all the things you want to do. It improves tissue oxygenation. It thins the blood, making it lower in viscosity. It helps prevent atherosclerosis. It helps reduce oxidative stress. Helps reduce diabetes, helps prevent the patient from being obese. So obesity is a major risk factor for cancer. Lowering dietary protein, especially, most importantly, lowering animal protein, has multiple effects. Animal protein has more methionine and more cysteine too, but especially more methionine, and that has a sulfur group that gets metabolized to sulfuric acid in part, and then the buffering process takes some calcium from the bone. It also gets some calcium from other locations, and that is excreted in the kidneys, causing increased urine calcium. That's called calciuria, which predisposes to kidney stones and over time gradually predisposes to kidney failure from the calcium precipitating in the kidney tubules, worsening osteoporosis when you've got high protein diets, especially high animal protein. High animal protein is associated with elevation of blood cholesterol. My simplified way of viewing it is high animal protein diet puts the body into a hypermetabolic phase, and then it wants to get up blood cholesterol. Time to build stuff, okay? High protein diets, especially with elevated leucine and methionine, which means animal protein, will cause more activation of mTOR, which is a nutrient sensing pathway to build stuff, to get the cell to grow and to replicate. So we'll talk about more of this, but what I'm also trying to do here is show you that a vegan diet doesn't just lower your risk of cancer in one way. It lowers your risk of cancer in like 35 ways, okay? And a high meat diet, processed food diet doesn't just increase your risk of cancer in one or two ways. It increases your risk of cancer in over 30 ways, all right? So I'm trying to help you develop this coherent rationale that makes it easy to do the right decision. For example, People will say to me, well, how can you stick to that diet? It's so restrictive. It's so narrow, And my wife said to me, you're like a effing robot. You would eat the grass if you thought it would make you healthy. And I've had a lot of people say things like that. Oh, they feel restricted and deprived. No, it's when you understand food. You know what's good for you, what's bad for you. You want to put good food on both sides of your plate. And when you understand it, it's easy to decide. You say, why would I want to, everything in moderation is just the voice of an idiot. Why put good food on one side of your plate and bad food on the other side of the plate? No, just put good food on both sides of your plate. It's pretty easy. And it's nice to feel good. It's nice to age well. As far as I know, and I know lots of doctors, I'm aging the best out of all of them, my own age, I would say. Of course, I'm biased in that opinion, but I think it's true. Okay, a couple points about cancer. Mainstream therapies, chemo, radiation, for example, they're great at killing off the bulk of the tumor and getting rid of the rapidly proliferating cells, but they do have a problem. They are often not able to effectively treat the cancer stem cells, which are more slower growing, often relatively dormant. And then is these cancer stem cells, which have a tendency to reoccur and kill the patient. So just because you do chemo radiation, you shrink the tumor, that does not mean the patient's cured. The tumor might be dramatically shrunk down, but there still could be living cancer stem cells in there prone to recurrence. And so, the chemo couldn't get to them maybe because they're too deep inside the tumor. The chemo couldn't effectively kill them because they're not actively dividing, such that it was not effective. Sometimes these cancer stem cells have developed multiple drug resistance membrane transporters. And as soon as the chemo comes into the cell, they'll pump it out. So that's why you need to have more than one thing going on to prevent these cancer stem cells from taking over and growing. There's things one can do. By the way, here's a paper called Targeting Cancer Stem Cells by Fang Yu from 2019. Here it is, the reference right there. Other things you can do, of course, by avoiding meat and iron in other sources like reinforced grains with iron or multivitamins with iron in them. One, lowers their oxidative stress and inflammation. Avoid all the things that cause leaky gut. You reduce your bodily inflammation. Inflammation can lead to tissue ischemia and end up favoring cancer. It also causes the release of acute phase reactants, which is going to make the blood more prothrombotic, activating platelets as well. Activated platelets have a tendency to help hide metastatic cancer cells, so they increase the risk of cancer metastases. You want to avoid leucine and methionine. We talked about that. The animal protein and amino acids. Animal protein has a lot more of the amino acids, leucine and methionine. Methionine in particular is an essential amino acid that's quite problematic. And so avoiding it, we're going to talk about methionine restriction, helps reduce aging by slowing down mTOR, cell replication. And that's going to delay the rate at which one reaches the Hayflick limit. We'll talk about that in just a moment. Avoiding advanced glycation end products in the diet will also help prevent thickening of the capillary basement membrane to improve tissue oxygenation. And the point I'm going through all this is to treat cancer, you don't just take chemo. I think that would be one step. Why not do all these other things and have a better chance? Do them all together, have a better chance at a great outcome. And you may or may not need chemo. Some things you do, some things you don't. But it's good to know about all your options. And we talked about avoiding sodium vasoconstrictor, which will tend to make tissue hypoxic, thus favoring the cancer growth. Also, when you avoid salt, you're avoiding sodium chloride. The chloride itself has a negative charge on it, as does bicarbonate in the blood. So it's a negative charge Cl- will displace the HCO3-, the bicarb, and thus it'll lead to a mild metabolic acidosis. Acidosis favors cancer growth. So plant foods, you get a lot more potassium and magnesium, vasodilators, helping to oxygenate the tissues, thus favoring the normal tissues over the cancer. All these things add up and can potentially be very helpful. Okay, we talked about some of this before, but just real quick, exercise gets the lymphatics flowing. We talked about avoiding sodium and chloride for both the vasoconstriction of sodium and the chloride displacement of bicarb, leading to metabolic acidosis and an unfavorable tumor milieu. Avoid things that activate platelets, stress, caffeine, etc., inflammation. Okay, here's the structure of an amino acid. The structure is basically the carbon in the center of it is called the alpha carbon. That's the Greek alpha there. So it's got a carboxylic acid on it. That's why it's called an acid. It's got an amino group on it right here. That's why it's an amino acid. Okay, and here's the alpha carbon. There's always going to be a hydrogen up here. And then down below is the R group. Okay, so here's a symbol for drawing an amino acid, just putting an alpha in the center. And to keep it simple, the only thing that varies is the R group. So you can just write alpha R. All right, and then I had a lecture, a couple weeks ago on biochemistry of amino acids, and for our purposes, all we care about is knowing about methionine. So here's methionine right here. Methionine. I just showed the alpha group, and then 2 carbons like an ethyl, and then the sulfur group, and then another carbon, a methyl. And that's the structure of methionine. So the key point is that it's got a sulfur group in there, and that sulfur, as we spoke about, gets metabolized in part to sulfuric acid, creating a low-grade metabolic acidosis, which has to be buffered, which has an end result of leading to more calcium excretion in the urine, calciuria, increased kidney stones, increased kidney failure over time. The methionine also has a tendency to participate in methyl cycles. It's got this methyl group hanging out in the breeze, and so that's real strongly related to folate metabolism and to DNA synthesis and to the enzyme thymidylate synthetase. So that's all going to be relevant. Methionine is a super important amino acid, and it's needed for the cell to replicate because it can't make your DNA without having methionine. You need that for your thymine. Okay, so here's the overview concept of what does it mean to restrict methionine. What it means to restrict methionine is it's a way you fight cancer. Okay, so here is Napoleon. Napoleon's coming in, charging in to attack your country, wants to take you over, make you turn everybody into French people. All right, and then the Russians figured out how to beat Napoleon. All right, what they did was a scorched earth policy. They basically said, no, we will not let you take over our country. We will not give you any food. Napoleon was like an army marches on its stomach. Everywhere he'd go, he would steal the food from all the farmers and all these poor people. And so what the Russians did was they'll say, hey, we'll burn the crop field. You are not going to get any food from us. And Napoleon went into Russia all confident with, I forget the exact number of men, 500,000 or more. I forget the exact number, tons of them. And he left with hardly any. He lost almost all of his army. It was a big disaster for Napoleon. So that's how you fight cancer. You don't give it what it needs. Cancer needs lots of methionine to make its DNA so it can replicate. Don't give it methionine. Cancer needs lots of iron to replicate and to run its other enzyme systems. Don't give it iron. It needs leucine also to activate its mTOR for cell replication, cell growth and replication. Don't give it leucine. Leucine and methionine, they both come primarily from meat and other real high-fat foods. We're going to talk about that. That's actually going to be an interesting point. And you want to exercise a lot so your white blood cells are running all over your body looking for that cancer, finding it, and removing it. You want to avoid doing the things. The high-fat diet is also leading to glycation and decrease immune system function. Control your stress so your cortisol is not high so your immune system will function better. There's a whole bunch of things you could do. But this is the main point. Don't give cancer what it needs to grow, and you've got a real good chance to slow it down. And I was real happy when I was looking at these charts just last week, and I was looking at these advanced glycation end product charts. I'd read the papers on that the previous week, and then this week I started reading the papers on methionine. And what I saw that made me real happy was the realization it's pretty much the same things that are high in methionine are also high in advanced glycation, dietary advanced glycation end products, and it's internally consistent. And basically, when you've got a good explanation for something, this is typical, it all lines up. Like T. Colin Campbell said this in his book. I'm rereading his book again, chapter 3, where he's talking about this stuff with regard to cancer. He says cancer doesn't just increase, animal protein doesn't just increase your risk of cancer in one way, it increases your risk of cancer in numerous ways. The more you look for it, the more you will find. And the same thing like good food, like eating fruits. The more you study fruits, you're like, gosh, they got more and more good things. I think we're kind of made to eat fruits. Look at our eye. We got color vision so we can see when fruits are ripe. Anyways, all this stuff lines up. Eating a diet very low in fat and very low in protein. You live longer. You're thinner. You prevent diabetes. You prevent coronary artery disease. You prevent impotence. You prevent cancer. It's good across the board. It's not just one diet for cancer or atherosclerosis. It's the same diet very prevent all of these diseases otherwise known as chronic. And chronic, by the way, means the disease never gets better. It's simply managed. And with very low fat, low protein, you tend to prevent all this stuff. You could still get cancer. Cancer's complicated, but it's much more rare in persons who eat this way and also have these good lifestyle habits like we're talking about, being sedentary, exercising instead of being sedentary, for example. Okay, here's a paper, Advanced Glycation End Products and Diabetic Complications. And the relevance was, first of all, the paper says, diabetes and its complications are rapidly becoming the world's most significant cause of morbidity and mortality. That's a big statement. What they're saying is diabetes is the most important disease in the world. And I think that's probably true. Diabetes and hypertension all day long. You don't even have to show me the chart. If somebody tells me I got a 60-year-old patient with cognitive impairment, I don't need to see the chart. I automatically know almost with more than 90% certainty that patient is diabetic, that patient is hypertensive, probably has had at least one cataract surgery, and has poor dentition. I just know that, and has coronary artery disease, okay? That's almost the way all Americans are as they get older, because they're all eating high-fat diets and plugging up their arteries and causing insulin resistance and diabetes and hypertension. Okay, and so the good news is all this stuff is dietary. And so the best thing you can do is optimize your diet. There's also a component in toxicology. We'll talk about that in separate lectures. But this is reason to be hopeful. When somebody tells you, oh, it's just genetic, that's like a hopeless thing. There's nothing you could do to change your genetics. Another thing they talk about is in this review, they felt that advanced glycation end products were the main mechanism by which diabetes caused its complications, causing fibrosis, sclerosis, stiffening of tissue so they can no longer function correctly. This is just another thing showing how the advanced glycation end products would bind to the receptor for advanced glycation end products called the RAGE receptor, and that would activate all these secondary pathways, including something called nuclear factor kappa B, which then changes gene transcription and causes all kinds of inflammatory secondary processes, cytokine storm, and all kinds of things. Okay, well, the main thing people have heard about with advanced glycation end products is a way to follow blood glucose control over the course of the last 3 months. Red blood cell lives for 120 days, which is about 3 months. And hemoglobin inside the red blood cells gets glycated. And so checking the amount of glycation of hemoglobin in RBCs tells you what blood glucose control has been for the last 3 months. Because once it's glycated, that's irreversible and it'll last for the rest of the life of that red blood cell. Okay, here's just a quick summary of carbohydrate classification. Monosaccharides is one sugar unit, and the one we really care about is glucose. That's the most important sugar by far than all these. Second most common sugar people talk about is fructose, but glucose is by far more important. Disaccharide is 2 units. The main one we talk about is sucrose, which is a combination of glucose and fructose. Oligosaccharides is several sugar units. That mainly relates to digestion with something called dextrins, when you're starting to break up your starches. When you look at polysaccharides, more than 10 sugar units per molecule. You got your digestive sugars like your starch and the different issues on that. So the main thing we care about for the purpose of this lecture is what's called formation of advanced glycation end products. And then really what I'm especially getting at with this lecture is methionine. But the reason I was happy and excited to give this lecture was when I looked at all the charts of what's high in advanced glycation end products from a dietary point of view and what's high in methionine is pretty much the same stuff. Primarily animal products, but also high-fat foods. But it's especially animal products, okay? And the higher protein foods, of course, are going to be a little bit higher in methionine in general. So a molecule of glucose, when it's in the in the linear form, open form, that's called, it's like a fishing rod. It's the Fisher projection down here, Fisher projection. And it's like a fishing rod, a linear chain. That's when it opens up. But most of the time in solution in the human body, which is an aqueous solution, it's going to be in this configuration, in a ring configuration. Okay, and then it briefly opens up to the open form, and then it goes to the other type of the ring configuration. The two variations are whether or not the hydroxyl group on carbon number 1 is pointing down or pointing up. Okay, but what we care about is the higher the sugar, the more is going to be in this open configuration, which can potentially glycate stuff and cause tissue damage. All right, so here is a hemoglobin molecule, for example, and it could be any other protein. And you can form glycation to a lysine residue. You can glycate the end of the molecule where the amino group is sticking out. And once it binds to that, this glucose molecule bound to that protein, this will become irreversible. That's why it's called advanced glycation end products, because they're irreversible. It's more important in proteins that stick around a long time. Collagen is the most common protein in the body, and it sticks around for a very long time in a lot of locations. So glycation of collagen is a big deal. It stiffens it, makes it less functional. In a red blood cell, we talked about red blood cells live for 3 months, typically 120 days. So that's why hemoglobin A1C is relevant for your estimated blood glucose control your last 3 months. Okay, the big deal about glycation end products is normally here's a capillary, here's the red blood cells going through a capillary, here's the oxygen, little blue circles coming off the red blood cell to provide oxygen to the tissue, in this case a neuron, okay, in your brain cell. Now here's the point with diabetes and hypertension. This yellow thing is the capillary basement membrane. These are the endothelial cells, the lining cells of the artery, the little spindle-shaped cells of the nucleus there. So this capillary basement membrane, this yellow part, in diabetes, And in hypertension, it gets thickened. Notice how it's thinner up here, it's thick down here. And when it gets progressively thickened, that makes it harder for the oxygen to pass from the red blood cell to the tissue. So we've talked about it. The more hypoxic, the worse oxygen delivery is, the more likely a cell is to go into a Warburg effect and become cancer. So you want more oxygen going to your cells. So this is my point. Diabetes and hypertension, by causing progressive capillary basement membrane thickening and atherosclerosis, they're decreasing oxygen delivery to the tissues. They're increasing cancer risk. All right, so now we're going to start getting more into methionine. So here's a paper on targeting the methionine addiction of cancer. Unlike normal cells, cancer cells need lots of methionine, plus they're less skilled in handling it. They're much more vulnerable, a cancer cell is, to not being able to grow at all when methionine levels are low. In addition, cancer stem cells are thought to be sensitive in many cases to methionine deprivation. So the big thing killing people with cancer is that these cancer stem cells recur after the initial tumor shrinkage. And the whole point of this article is there does appear to be evidence that methionine restriction might have a good chance to prevent the cancer stem cells from coming back and growing, and thus save the patient, keep them alive longer. And I wish I knew all this stuff back when my mother had cancer, because maybe I could have kept her alive longer. And, you know, my mom did pretty well. I mean, everyone thought she'd be dead in 2 to 3 years, and she ended up living about 11 years. So and I know the oncologist really liked my mom. His wife loved my mother. She moved into our house. She was a nurse, and she slept in the same room as my mother and took care of her while she was going through chemo. That's how much she loved my mom. Okay, low methionine content of vegan diets can make methionine restriction feasible as a life extension strategy. I tell you, you're going to find tons of articles on this. This is well known, and this is a very important thing. And they're talking again about vegan diets are low. So pretty much a methionine restriction diet is a low-fat vegan diet. And a little bit on the low-protein side. Okay, additional thoughts. And like I said, I called it an AO. That means academic orgasm. When I realized methionine and advanced glycation end products, they're in the same foods. All the animal foods, high-protein foods, and have more. And really high-fat foods tend to have more as well. And so this also reinforced, you know, what I had been convinced of a long time ago, that a very low-fat, very low protein diet is best. You know, like Kempner was really on the right track with his. I'm not saying being as strict quite as Kempner, but what I am saying is that's a whole group of nutritionists, the low-fat vegan experts. That's like Walter Kempner, Caldwell Esselstyn, John McDougall. I think they're all on the right track. And then there's a separate school of vegan experts that are recommending a lot more fat, so-called good fats, olive oil, soy, and nuts and seeds. And I think that, my personal opinion, after having studied that some, a pretty good amount, I think that's a mistake. AGEs are much more common in animal foods, of course, very high protein and very high fat. And among plant foods, they're a lot more common in the high protein, high fat plant foods. Okay, reasons to avoid these foods: anything with high fat, you're going to predispose to obesity, diabetes, hypertension, coronary artery disease, so that's bad. Advanced glycation end products, meaning tissue damage, that's all bad. And then a wonderful thing, another AO, is you only got 1% fat in white rice, potatoes, sweet potatoes. That's why I think those are the best foods in the world. I like sweet potatoes a little better than regular potatoes because they only have about 4.5% of their calories from fat. Regular potatoes have about 8.5%, 9%, so call it twice as much protein as sweet potatoes of their calories from fat. Of calories from protein. They all are 1% calories from fat, but this is 4.5% calories from protein, about 9% calories from protein, about 5% calories from protein here with rice. Okay, and I think that's why, you know, these Japanese people in the 1970s, they lived so long, even though they're smoking a lot and putting tons of salt on their food, that rice is such a great food, it protected them. And same thing in Papua New Guinea. They smoked a lot of cigarettes, but they were eating so many sweet potatoes, is like 93% of their calories, which gave them a total protein amount of around 4.5%. It kept them healthy. Not hardly any lung cancer, relatively speaking, compared with an American who simultaneously smokes and eats a high-fat diet. That high-fat component, it appears that what's going on is it's causing more tissue hypoxia, so they would get a lot more lung cancer. What about methionine restriction? Why does methionine restriction prevent cancer in mice. It's slowing aging, and it's increasing mouse and rat longevity. And so we think it's because it makes it so the cancer can't grow, and it slows down the arrival at the Hayflick limit. Methionine is an essential amino acid. Humans can't make it. It must come from the diet. It slows mTOR. mTOR means mammalian target of rapamycin. mTOR is a nutrient-sensing pathway. mTOR is a contractor getting ready to build a building, and it can't build the building until all the materials are available. The rate-limiting step is methionine and leucine, both of which are much more common in these foods we talked about, especially animal protein. When methionine and leucine are available, mTOR cells can grow and replicate, and it accelerates arrival at the Hayflick limit. Hayflick was a microbiologist who worked with human tissue cultures, and he found that they only divide about 60 times, and then they go into senescence, where they sort of stop dividing and they actually die pretty soon, relatively speaking. So you don't want to reach the Hayflick limit. That's accelerating aging to speed up reaching the Hayflick limit. So eating a lot of animal protein accelerates your aging. Now, if you're a 20-year-old bodybuilder, you might want something that speeds up cell growth a little bit to increase the speed at which you can build a muscle. But when you're over 30, and especially if you want to age well and you're afraid of cancer, you want to turn down mTOR a bit, slow down cell growth and cell replication. Okay, cancer cells need methionine to grow. Methionine restriction deprives the cancer of methionine. And that's been shown to be a big improver of longevity in mice and in rats, and there's good reason to believe it would do so in humans as well. You can look at the vegan diet as a surrogate methionine restriction diet. And like I said, I was real excited when I realized that methionine, the same foods that are high in advanced glycation end products, especially meat, high in animal protein, and foods high in fat as well, are also high in methionine and high in advanced glycation end products. And so that's another reason why I'm not a big fan of seeds. Seeds have surprisingly high both advanced glycation end products and methionine. Nuts, I put them in yellow light. So I'm making these red light. I put nuts in the yellow light. I don't eat them except maybe a spoonful on a holiday. Beans are kind of a high protein food, but they've got a lot of good nutrients to compensate, and they're relatively low percentage-wise in methionine. Then grains, and then fruits. Fruits incredibly good. Avocado is a little less good than other fruits, but not that bad. So again, this is helping to show the 1 billion rice eaters in Asia can't be wrong. Kempner was right on. Potatoes are great too. Okay, and I felt like I was winning the jackpot on the slots at Vegas, realizing all these things all go together, which increases one's confidence. When you see a coherent, plants are just better in numerous ways. Not a few ways, but almost every way you could think of. So here's some numbers on the amounts of advanced glycation end products in foods. When you take white bread and you toast it, it turns brownish. That's producing advanced glycation end products. These meat products like fried bacon, hot dog bread, we're looking at 10,000, 12,000 units of AGEs. In comparison, you look at a fruit, an apple, 13, banana, carrots, 10. Almost nothing in plant foods compared to these animal foods. And then these really fat foods have quite a lot of them as well, like olive oil, mayonnaise, avocado, toasted bagel, a lot of these just exogenous, coming from outside the body, dietary advanced glycation end products. And it depends on what you read, what exact percentage of advanced glycation end products are absorbed. One article says 20%. So they do contribute significantly to advanced glycation end products within the body. The other ones are the ones produced intrinsically inside of you by the hyperglycemia and diabetes. Okay, now here's some numbers for methionine. With the methionine content given in milligrams in these foods, 1 ounce, by the way, equals about 28.4 grams, because you'll see that in a lot of charts. They're going to be grams of food relative to milligrams of methionine. So look at this: beef, chicken, tuna, they're all off the chart, super high in methionine. So a 3 ounce serving of beef, 650 milligrams of methionine. That's a ton. Okay, all of these animal products are really bad. Brazil nuts, also tons, even more than the meat, off the charts high in methionine. So that's something to make you a little less thrilled about Brazil nuts, especially if you have cancer. I wouldn't eat them. Flax seeds, quite high in methionine. I would probably ballpark them at a little bit less than half what you get from your meat products. Chia seeds also quite high. Sesame seeds also quite high. They're actually more than half what you get from your animal foods. Now, beans just have a lot of protein in them. So they'll have, about a third of what the meats have in terms of their methionine percent of calories. Okay, when you get to the grains, that's even lower. Oats a little bit high. All right, not too bad. Same with quinoa. Quinoa is a sort of a high protein starch. I seldom eat quinoa or oatmeal, but they're okay. They're a decent food. White rice is lower. I think that's even better. Green beans lower still. And it's got things like carrots, spinach, kale cup. These are all very low. Avocados are a little high, not that bad, but they're a little high with all the fat, and it just makes me think of that was kind of what I was getting at. The high fat fruit is the one that's bad for methionine as well as for AGEs. Now look at this: apples, fantastic, 1 milligram methionine from a cup of apples. Pears is about the same types of number. Banana and blueberry super low as well. So yeah, fruits really come out looking good when you look at them closely. They're real low in protein, high in antioxidants, pretty good in fiber, high in potassium, high in magnesium, exactly what you want. Very low in sodium. Oh, a couple thoughts on fruit. Our color vision helps us see when they're ripe. They taste great. The only bad thing about fruits is they're kind of expensive. They're kind of seasonal. I worry about what's on the coatings on apples. I noticed that I always liked apples okay, but I recently was eating apples last year, and I find myself eating 10 at a time. I'm like, why do I like them so much? Why do they all taste good? And then somebody told me, well, maybe they spray something on the coating like MSG. I don't know if that's true. Somebody said that though, and I couldn't understand why was I eating so many of them. I couldn't stop eating them. They tasted so good. And somebody also said they're concerned that maybe what's on that coating of apples. It's a little thick. It's hard to wash off. Does that get absorbed into your body? I don't know. If somebody knows the answer to that, please put it in the comments. I tried looking it up. It's actually a little bit of a challenge to look that up. I wasn't able to quickly find the answer to that. Some fruits are quite difficult to clean. The regular surface like strawberries, raspberries, grapes. So I don't eat those things. Grapes also have such a thin outer shell, and I worry if they're pesticide sprayed, does it just get absorbed into the fruit, and how do you clean a grape? Other things I love about fruits: they're low in fat, real low in protein. They're alkaline, which helps to create a milieu around cancer cells that helps prevent the cancer from growing. They're high in antioxidants, all the colorful components. Okay, now we're going to talk a little bit more about methionine and go through some of the scientific papers on the subject. And by the way, you're going to find lots of papers on the subject. One thing I noticed too, sort of a red flag, is when you start looking up some of these methionine papers and their benefit in preventing cancer growth, you keep running into paywalls. Oh, you can't read this article unless you pay. You can't read this unless you pay. And in my personal experience of having read lots of scientific research papers, when you start seeing a lot of that, a lot of times it's because somebody's trying to hide that information from you. And, do I know this for sure? No, but that's what it seems like to me. Why make such an effort? Even when it says free article available, I'll click on it and then it won't let me read it. So it's as if somebody wants to hide methionine restriction from you. So basically, a lot of work has been done on this. Sure, you'd like more work to be done on it. And they'll go through some of the different potential mechanisms. But it's very promising, and I think this is what I'm sort of saying here is, to be coherent, these patients, maybe they just got lucky, miracle from God, these two ladies who cured themselves from metastatic breast cancer. I know of other ones who have done so as well. Not my own personal patients, but that I've read about. This book, Radical Remissions, is quite interesting. This is by Kelly Turner, PhD. And she went and studied all these patients who survived metastatic cancer. She interviewed them, and she wanted to find out, what did they do? And so one of the things she found was pretty routine. They did this diet. They went on no meats, no sweets, no dairy, no processed food. And like I said, this other one said raw can cure cancer. So, how useful is that? Is it all just a coincidence? I don't know, because you don't have any big research study. No one's got a whole big research study of low-fat vegans and how their outcomes were. But when you read all these case reports, all these people who survived metastatic cancer, that's a common thread. And, here these ladies are alive, 20, 30, 40 years later, running marathons and stuff. Holy crap, okay? They're a lot healthier than most young people are. Okay, here's an interesting article on methionine restriction in cancer biology. Here's the paper, and the next couple slides are all going to be from this paper. Methionine restriction inhibits cancer cell growth and may enhance the efficacy of chemotherapeutic agents. Maybe this should be used on a much more common basis in conjunction with standard chemotherapy, okay? That really should be explored. It has a tendency not to get explored. There's no money in it, but it might be a really good thing. We don't know how good it is. Okay, so eliminating methionine in the diet of animals or cell culture provides metabolic benefits. It decreases adiposity. Well, people are less fat. Animals are less fat when you're avoiding animal foods, methionine. You get more insulin sensitivity when you avoid the high-fat foods, which makes you skinnier and helps prevent atherosclerosis, helps prevent capillary basement membrane thickening. This is what I kind of meant by the good stuff keeps on making more good things happen. And then the bad foods, the animal foods and the real high-fat foods, they keep on making more bad things happen. So that helps confirm. So when you methionine restrict, you get less oxidative stress. You get less inflammation. You have improved autophagy. Think of that as improved ability of the bodily tissues to recycle themselves when they need to. And you get increased longevity in mice and rats, and you get less cancer. That's all good. Okay, another point they make that our own body cells can handle methionine better than cancer cells do. The cancer cells lack the enzymes to sort of run the cycles between homocysteine and methionine. So when you methionine restrict, it has a much bigger effect on cancer cells than our own human healthy cells. So what am I getting at here? One of the problems with chemotherapy is a lot of them have too many side effects and they cause a lot of suffering in the patient. And what these articles are basically saying is methionine restrictions, like eating a low-fat vegan diet, it's not doing any damage to these normal cells or no significant damage to these normal cells, all right? So now you're getting what you really want, something that makes life difficult for the cancer, but doesn't affect your normal healthy cells. So a much better side effect profile. So either done on its own, methionine restriction, or done in conjunction with chemo, it appears to be something that will facilitate minimizing cancer, but maintaining good function in your own body's cells. Trust me, that's an incredibly good thing. Okay, here's the last slide. The methyl cycle, sort of along the single carbon metabolism and folate metabolism for DNA synthesis, especially we're working through thymidylate synthetase, which is important for making thymine, in your DNA. And what they're saying is, for example, there's a chemotherapy drug called 5-fluorouracil, 5-FU. And when it's given to cancer patients, the cancer cells often figure out how to become resistant to it, okay? They can increase the amount of thymidylate synthetase enzyme they make and thus overcome the inhibition of it by this chemotherapy drug. So the point of this article was, well, guess what? Methionine restriction seems to selectively prevent these cancer cells from growing without doing harm to the body's normal tissues. That's what you want. An effective drug with minimal side effects, if any. So there's something called triple negative breast cancer where there's no estrogen receptors, no progesterone receptors, and no HER2, human epidermal growth factor receptor type 2. So that has fewer drug treatment options when a person has breast cancer of this type, triple negative breast cancer. So the point this article makes, and it's a smart point, well, gee, wouldn't these patients be perfect to add methionine restriction to their treatment as a way to potentially prevent that cancer from growing? And I think it's true, it's obvious, and it's smart, and it's good, and so hope this was helpful.